Hello and welcome back to another VMK in the game development series. In this VMK, we'll be introducing a headlight to our player. A headlight is called a headlight because it's a light source that's sitting on the player's head. So whenever the player moves, the light source will move with it. Now let's take a look at what we already have in our game engine. Let's just run our previous demo here. Okay, as we see, we have a cube that's rotating in front of our faces. As we move around, we notice that there is a light source in the scene because the sort of grid right below us is illuminated, and the front of the face is also illuminated. If we walk around behind the cube, we notice that the back side of the cube is completely black. And it's because the light source is not shining from this side. We're not holding any light source here to illuminate the back side, so it's completely dark. Well, let's add a light source to ourselves so that when we move around, we can have the light move around with us. That's basically a headlight. To do this, let's start off going into the scene here inside Initialize. At the very top here, we have initialization for light sources. And currently we are starting off with just a point light source, which we have right above the scene. Let's actually take this guy out for now and make sure we have a completely dark screen like this. The other thing that I'm going to change is inside of the update, I'm going to disable this so that our cube doesn't rotate any. Let's just build this and make sure we have everything's basically not visible because we no longer have a light source in our scene. Well, now let's add a light source, and again I'm going to add the exact same light source, but this time we're going to do something different with it. Actually, instead of using a point light source, it's better demonstrated if I use a directional light source. And a good directional light source is a spotlight. So let's create a spotlight here. We initialize it using our light spot class, and I just set the attenuation, the cutoff, and exponent here to a couple numbers that I was playing around with to get some neat effect. And then we call add light so that this light that we just created here with the new is stored inside of our container, which then gets emptied whenever a program calls delete all lights. Okay, let's take a look at what this looks like right now. Oh, redefinition of P light. Let's just comment this guy out and try that again. Okay, so we have a spotlight and it's located at 000 and it's pointing straight ahead in the scene. Now notice something interesting here. As I'm moving, that spotlight is not moving at all. It's stationary at 000 and it's pointing straight inside the well, I'm not actually sure which direction it's pointing in. Let's take a look at what the default settings are for spotlight. If we go under light spot, take a look under the constructor, and it doesn't look like we defined a direction. Well, we can quickly correct this just by going inside of our scene here, and let's set the direction of this light source. Set direction, and we need a vector 3. So I'll make it point in the 0, 0, -1 direction. Nope, I missed a bracket here. Okay, so I think that was the default direction because it doesn't look like it changed very much from our previous render. Alright, now what is our spotlight actually doing? Well, it's illuminating our vertices. It's not illuminating our pixels, which is kind of a problem because if we have objects like our cube, for instance, that don't have very much detail, the light itself doesn't shine very much in the scene. And I can demonstrate this a little bit better if I were to put another object inside of our scene here. Let's see, we have our box, and we have our flat grid here, and okay. What I'm going to do is I'm going to reuse our geometry flat grid. Actually, no. I'll create a new geometry flat grid, and I'll place it right in front of our faces so that you can see how much the spotlight is actually illuminating. So I'll name this geometry flat grid, and I'll call this pointer plane. And I'll make it of size, we don't want it too big, so let's go with just 1 by 1 maybe, and we'll do 20 by 20 divisions. Okay, so we save that geometry, and then we need to create a new shape node, and this guy is going to be using p-plane, and then we need to add him underneath of a certain node. And which node should we stick him under? Well, we don't have one to actually use ourselves, so let's go and create a new transform node to stick him under. Let's do that right here. And we'll move this transform MV3 translate. Since we have our box 3 units back, we'll move the plane to be 1 unit back. So we'll just go MZ equal to -1, like this. And then we'll call this guy UI node ID. He's underneath the root. And then inside of our shape node, we'll call UI node ID here. Okay, so that should do the trick. Let's see what this does. Where is our plane? Okay, oh right, the plane itself is horizontal. It lays flat in the screen. So we're not actually going to see it until we rotate it up to be like sort of facing perpendicular to our ground. And we can do that by the following code. We take the rotation axis of the plane, or actually of the node transform that the plane is nested under, and we rotate about the x-axis 90 degrees. So this is going to rotate everything to sit straight up on the screen. Now, when we go and build and run this, okay, now we can see that plane sitting in front of the box, which is behind it. And on the plane, we can see that spotlight. It's pointing straight ahead, I guess. The spotlight itself is located at 0, 0. So we could move it up if we wanted to, for instance. We can go p-light set position vector 3 0.0f 0. Well, we want to move it up, so let's go 0.5f and 0.0f. Oh, I missed another bracket. Okay, now it's a little too high, so let's do half of that. Okay, so there's our spotlight. It's pointing straight ahead. And if we now go and remove that plane, we can actually just remove this shape node here. I guess we have to comment it all out, or else we'll have a memory leak. Okay, we now see that it's illuminating the front face of that box completely. You notice there is no circle formed on the box itself like there was when we had the plane in place here. And again, this is because the spotlight works on vertices, not on pixels. So the box itself is made up of 4 vertices coming basically on the front face there, but this plane is made up of a bunch of vertices, and you can actually see the circular part of the spotlight is kind of jagged on the edges because those are where the vertices are on this plane. Now, what we want to do is be able to attach this spotlight to our head so that when we move, the spotlight will also move. To implement this is actually quite easy. All we need to do is go inside of our scene player update. Inside here, we call mPlayer's update with the specific time that was passed into us. After this function returns, we've updated the position of the player. So after we've updated him, we can then update the position of our spotlight. Now, the way we're going to use the spotlight is kind of special because inside the scene, let me go back into initialize here, we can have multiple light sources defined, but we're going to say that the very first light source we define is going to be defined as the headlight. So inside of our code, whenever we need to access the headlight, we'll always look for it as the first item inside the container of lights. Let's go back to where I was before now. Okay, so to move the headlight, we first have to make sure we have a light source saved. And we're saving all of our light sources inside of our member variable called mvp, mlights. Actually, you know what? I'm going to rename this just because all the other ones we've used MVP for the naming notation, so we're going to rename this guy to be MVP Lights. This will probably give us a bunch of error messages, but we'll go and correct them whenever we find them. So back in here, we'll use if MVP Lights dot size is greater than 0. So in other words, we have at least one light source stored inside this container. Then we can access the very first one, like this, and we can set its position. So set position. Okay, we can't do that because I forgot that set position is only available for specific lights. And if we go back into our lights here, we notice that the spotlight has set position down here. The point light source has set position, but the directional light does not have a set position. And as a matter of fact, our light class, which everything inherited from, does not have a set position, where this guy here is actually a light pointer. So it's pointing to a light object. It doesn't really realize that it has set position because this is from an inherited member. So what we can do is we can modify our light structure here to include set position. So let's go inside of our light class, and we'll create another guy here, and we'll put him right here. So we're creating a virtual function called setPosition, which has to accept a vector3 of a position, and we're making a pure virtual function here, so it's equal to 0. Now setPosition will be defined for our light class, which means all of the inherited members have to have this function. And this is not a problem for the point light because it already has a set position, and spotlight already has it, but directional light does not have it. So we need to add a dummy function that gets handled here by the set position. So let's go inside light directional, and I'll just put it really anywhere, just down here, set position, and we're not going to do anything inside it because the position for a directional light has no meaning. But because we're defining it here, we need to make sure that inside the .h file we also include it. Like so. Okay, so when we make this change, we can actually go back into our light.cpp file, rebuild this guy, or actually recompile. Once he's recompiled, we can then go back into here, and now if we go set position, it shows up for us. Okay, we need to pass in a vector 3 for the position we want to set this light source. Well, the position we want to use is mPlayer, right? So we're going to take the player's position, get position, and feed it into the light source. You would expect this to work now, wouldn't you? Let's go and take a look at it to see what happens. Well, as a matter of fact, we're going to get a bunch of error messages because we've changed our naming structure here for the light container. So we'll just have to quickly go through all of these, and wherever m_lights is, we need to go and replace it with mvp lights. VP, VP. It may actually be faster just to do a find and replace, but just to make sure I don't get something I don't want to, I'll just do this by hand because I don't think there's really that many of them to find. Almost done here. 2 more. VP and VP. Okay, let's try this. Okay, now let's go and run. Alright, if I move backwards, you notice we don't see any light. If I move to the left, nothing, nothing. Don't see anything. If I move forward, oh, there's something getting lit up here. It's getting lit up, and it doesn't seem to be really working. Now, why is that? Well, if you remember back to the video that we did with the camera itself is the reason for all of these problems. When you move objects in the scene, you have to move them one way, but when you were moving the camera, you had to move it exactly the opposite way. So, for instance, whenever we moved an object 3 units forward, that means for the camera we move the object 3 units back, or we move the camera 3 units back from the object. Same thing applies here with the light source, because now it's attached to our camera. So let's go back into our function. Where was it? Scene player update. And instead of getting the position of the player and setting that to the light source, we need to take the negative value of the player's position and set that to be the light source location. Now let's go build this. Oh, we're getting a error message here because vector3 does not have a unary operator defined for it. Well, this is easily fixed if we just go inside of our math library for vector3 and take a look at what we have here. We have our operator for minus equals, our times, and our plus equals. Well, we can add in the unary operator as well. I'll just add it here underneath the minus equals. So all we do is we have vector3 operator minus with 2 brackets and then a constant, and we just return a vector 3 with the negative of the x, the negative of the y, and the negative of the z. So that should take care of that error message there. Let's go and build this. Okay, and let's go and run it. Okay, now you can see as we get closer and further away, our spotlight seems to be getting larger and smaller. Well, this again makes sense because as we move further and further away, the cone angle of the spotlight is getting larger and larger. So that's why it's filling up more and more of that plane. As a matter of fact, let's move that plane up a little bit just so it's easier to see the cone angle here. Inside of our scene initialize, right at the very bottom here, we translated back one, and let's just change this. Vector 3. We're not going to move it in the x direction at all. We're going to move it up 0.5 units, and then we'll move it back 0.1 units. Okay, so there we go. We can see the circle of the spotlight getting larger and smaller. And if we move to the left, we move to the right, everything seems to be working correctly. Well, now look what happens though. If I were to rotate my camera angle, the spotlight didn't move. And why is that? Well, we're only updating the position of the spotlight. It's always pointing straight ahead, but it's not pointing in the direction that we're facing. So you notice if I'm looking up or down or whatever, the spotlight itself is not moving. We need to correct this. Anytime that the player changes his direction, then we need to also change the direction of the spotlight. The direction of the player is handled inside one function. And you remember this because if we go back into player action, you'll see here, anytime we perform any action on the player, we always call this one function. So if we move forward, back, left, right, or we're looking left, right, or up and down, we're going to call this one case structure here. If we're jumping or crouching, we call these down here. So if we're changing the direction that we're looking in, so left, right, up, or down, we're going to be going inside here. So we need to add some extra additional work here to update the spotlight as well. And here it is. So first thing we do is we check to see if we already have a light source. And again, we check our container for light sources. If it's greater than 0, then we know we have a headlight, because the first one has to always be the headlight. So we create a pointer to our headlight, and we get the value for the very first item inside of our container. Then, if our action here was looking to the left or right or looking up or down, then we perform some action. If our action was moving, then we don't have to do anything else because we've already handled the motion of the light outside in our separate function where we call player update. So if we are looking, we create this vector that's going to be pointing in the direction that the user is looking in. So initially, we always start looking in the -1 direction along the z-axis. We take this direction vector and we're going to rotate it about the x-axis by the angle that the player has rotated himself by, and we then rotate the result of that direction rotation here by the rotation about the y-axis by the same angle that the player rotated by. And then we set the direction for the headlight to be whatever this new direction here that we calculated. Now you'll notice that this actually generates an error message because, well, I wasn't expecting this one, but I was expecting this one. Okay, rotate x is not a member of vector 3. Let's take a look at this. Inside our vector 3, we have rotate y. So we need to create a new function called rotate x. And it's basically going to perform the same operation, but instead of rotating about the y-axis, we're going to be rotating about the z-axis, or I mean the x-axis. I guess up here in the comments I could say that this is a yaw motion, sort of side to side. Underneath here we're going to have rotate this vector about the x-axis by the desired amount in radians, and this is going to be equivalent to pitching up and down. So the three-dimensional math to take a vector and rotate it about an x-axis is shown down here. And then we return the result. Let's save this. Okay, so that should correct this guy, but we should still have the one error message. Right, set direction. And again, this is the same problem we had just previous with the set position. Our light.h does not have a set direction function. So even though we do have a set direction inside of our spotlight here, where is it? Set direction, you'll notice that the light point does not have set direction, but light directional does have set direction. So we can go and repeat the process by adding a set direction here. So we create another purely virtual function, set direction, which accepts a vector 3 and it's going to contain the direction. Save this, and we can close that guy. And now we need to go and add set direction to our light, point light. And I'll put it right here. And again, this is just a dummy function since a point light source has no meaning, or a direction has no meaning for a point light. Let's just copy this guy inside the .h file. And I think that should correct the problem. Okay. So now, again, we can move back and forth, but this time you'll notice that the spotlight is following the direction that we're pointing. So if we're pointing up or down, the spotlight is actually following us along. And now you can see here, as we travel around the cube, we can sort of illuminate the corners of the cube, or if we move far enough away, then we can illuminate the faces. So that's how we incorporate the headlight. Now, a spotlight is kind of neat because it has a sort of cone angle, so things appear darker or lighter depending on whether they're inside or outside the cone, but it's not very practical for low-res games or games that don't have high resolution meshes, because the objects themselves don't get illuminated properly, especially if they're like completely flat and large. So instead of using a point light source, instead of using a directional light source, let's use a point light source as our headlight. And that's actually going to create a much more realistic effect. Inside of our scene, underneath initialize, we can now go and delete this guy. We don't need him anymore. And instead, we're just going to reinitialize this guy. Now, set position here has absolutely no meaning because since this is going to be our headlight, it's always going to get overwritten whenever we move our player. So we can actually just delete it like this. And I'll label this as our headlight. Okay, so now you can see as we're moving, we have a light source that's moving with us, and it's illuminating the scene much more realistically, or at least it seems so because things are rendered much more nicely. We don't have that black spot on the back side of the cube because now the light source is moving with me. And if we wanted to, we can go ahead and go and add our original light source that we had here before. That's fine. We can have as many light sources as the video card supports. P-light set position, vector 3, I think we had 0, 5 maybe, and 0. Keep forgetting that second bracket. Okay, but now notice what's happening. Our light scene is actually getting very saturated because there's the light source from up above and there's the light source that I'm walking around with. So you have to be careful with attenuation values and how bright all of your light sources are. I can actually lower this light source and it won't look as bad because not as much light will be hitting the scene. Well, we have a really bright light source there, and I'm still walking around with the other one. But now notice the cube in front of us is lit at the front face, and if you can see that the back face is dark because that light source in the middle of the scene is not lighting it. But then as I start approaching to the back side of the face, it becomes lit because I have my own light source that's lighting that side of the face. The front face is completely saturated because that light source here in the middle of the scene is always illuminating it. So it doesn't matter whether I'm facing it or not, it remains lit. If you don't like how white or bright the light sources are, you can go ahead and change those as well. Again, inside the initialize, let's say we wanted to change our headlight color. Well, in here we can goplight, set diffuse color, and we need to use a color OpenGL, and let's set it to yellow, so that would be 255, 255, and 0. So now you see there's a white light source which is still hanging up above the scene, but now we're walking around with a yellow light source. So anything that our light source strikes will be yellow, everything that the other light source strikes is white, and then when we bring our two light sources together we get a mixture of the two colors. So if you didn't want the other light source to be so bright and white, you can actually change its color as well. Inside here, set diffuse color, and maybe we want to make it a little dimmer, so let's do 128. Actually that won't show up very well. Actually might not be too bad. Let's do that. 128, 128, 128. So this should be kind of a grayish color. So you see, it is lit, but no longer nearly as bright as it was before. You can still see it though, and our light source is full on yellow, and it's illuminating the scene as well. Okay, so those are the headlights and the other lights in the scene. Now, if you're finding my videos helpful and you'd like to see more come your way, for free, just help out my website. You can support it by clicking on the PayPal icon, sending me a donation. You can click on any of the Google ads, or you can join by becoming a member by clicking here, and then with a paid membership, you can increase the download refresh rate. So if you're trying to catch up with certain videos, you can take advantage of that. If you don't like having a restriction on the order in which the videos you're allowed to download, you can also purchase a membership, and then you can download the videos in any order you wish. One last thing I would like to mention here though is let's say you wanted to have the ability to turn your headlight on and off. And for instance, in a lot of games nowadays, you have the ability for your character to carry a flashlight, and the flashlight himself is basically like a headlight. You carry it around with you, and when you go into a scene, if it's dark, you need to turn your flashlight on, and then the scene will illuminate to be brighter. Your flashlight, if you turn it off, the scene will get dark all of a sudden. So let's implement that one last feature. To do this, let's create a function and place it underneath disable all lights. We'll call this function toggle headlight. And what this will do is anytime we want to turn the light on or off, we'll just call this function, and this function will turn the light source on if it's off and off if it's already on. So we check to see our light container to see if it's containing something. If it's not containing anything, meaning the size of this is equal to 0, we just return because this toggle won't be able to do anything. If this succeeds, we'll go down here and we get the first value that's stored inside of our container. We name it p headlight, and then we call a function called setOn for this headlight. And we've already created this setOn function whenever we created the light class. And the value that we set it to is going to be equal to the opposite value that it's currently on. So we check to see if it is on. If it is, it's going to return true, but then this not operator will make the value that gets passed into setOn equal to false. And the opposite will be true as well. If this returns false, then the not will make this true, so then we set it to be on. So there we go. That's our toggle headlight function. Let's add this to the .h file. Let's just put it under here. Actually, you know what? I'm going to move it down below to where all the other player functions are, right here. Actually, move it up. It has to be a public member because we're going to be accessing this function from outside of the scene itself. So underneath the player actions, we have a bunch of player actions, and then we can toggle the headlight on and off. Let's just try to compile this, make sure we didn't make any mistakes. Okay, that looks good. Excuse me. Now, to toggle the headlight is going to be a keyboard command. So let's close all of these just to clean things up. And all the keyboard commands come from the game engine. Inside game OpenGL, we have a function called handle keyboard. And inside here, you'll remember we have the keys to handle the motion of the player as well as the jumping and the crouching. Well, let's now add a new case here for toggling the flashlight. Okay, so let's paste that into here and call this turn flashlight on off. So anytime we press the F key on the keyboard, we're going to call the scene's toggle headlight, which is that new function we just created. Now you'll quickly notice that this is actually a bad way to do it because it doesn't give you very much control. So let's go and try this out and see what I mean. Okay, here we are in our scene. If I press the F key, you notice, I don't know if you'll be able to notice this inside the video once I encode it, but the light basically flickers and turns on and off really quickly. And what's really happening is I pressed the key on the keyboard, but because the computer is running so quickly, it turns off the headlight, but then it goes back into the same handle keyboard function on the next frame, and then it notices that key is still pressed, so it turns it back on. So it quickly turns it off, turns it on, turns it off, turns it on, and could do this multiple times depending on how quick your computer is running. So that's not really good. We need to secure the ability to turn on the light or off the light in a sort of reasonable manner without asking the user to like press and hold the button or press really quickly or something like that. And there's a sort of a simple way to do this by using a single variable. So let's take a look at that. Let's go replace this code with the following. We create this variable, dTimeDelay, and then we check to see our current game time to see if it's greater than the time delay time plus 0.3. If it is, we'll then call the scene's toggle headlight, and we set the time delay equal to whatever the game time is, and then we go through. So in other words, what is happening here is initially our time delay value is equal to 0. So then when we go and press the F key to toggle the headlight, the game time is always incrementing because it's always keeping track of what is the current time inside the game. So this is definitely going to be equal to the 0 plus 0.3 because 0.3 is very, very small period of time. So it's going to call this, and then we set the time delay equal to the current game time. Then, if you're still pressing and holding the F key, it's going to go in here. It's not going to reinitialize this to 0 because we've initialized it as a static member. And it's going to check the current game time and the difference between the delay plus 0.03. If this is happening on the exact next frame that we previously toggled, it's not going to go in here because 0.3 seconds is going to be a relatively long time with respect to the frames, but it's going to be a relatively short time with respect to how quickly you can press a key. Now you can play around with this number. You can increase it or decrease it to see what suits your needs. But it's a control to figure out how long can the user press and hold the button before it registers as 2 key presses on the keyboard. So let's build this and give this a try now. Okay. So now I'm standing here, I press F key, it turns off, press F again, it turns on. And if I press and hold the F key, you'll notice it takes a little bit of time for it to change between on and off. And the little bit of time is dictated by the 0.3. If I change this, for instance, to 0.9, then it'll take longer for it to switch between one and another, as shown here. See, it's slower between on and off, but you don't want to make it too long because if the player does want to turn it on and then turn it off again, then they won't be able to turn it off until that time delay has expired. So I kind of like 0.3. If you like some other value, feel free to plug it in here, but that's how you implement your on and off function. Okay, so that's about it. Sorry for the length of this video. It got a little bit long. I didn't realize there were so many different changes to be made with other functions, but everything should be now up and running with your scene graph and your headlights. So come back for the next video where we'll be adding the material class so we can actually get rid of our plain gray objects and start giving them some colors.